Why don't I flinch? Because the laws of science differ fundamentally from all other. My face.
Hi, welcome again, Science in 5. Type 2. Assemblage of charge. We want now the net force that is experienced by Q2. Let's start by drawing a free body diagram. So always draw a free body diagram. Whenever you see calculations of forces arising, make sure you've got the skill locked in. Check out one of our videos. We discuss clearly how to draw a free body diagram. So if I was charged Q2, there I am, because we want the force on Q2. Q2 is a negative charge. Let's see what Q1 does to Q2. Opposite charges, they attract. So Q1 pulls Q2. So there's the force from Q1. So Q1 pulls Q2 like that. Q3 is going to do the same. Okay. Now I can clearly see that I've got vectors that are acting in different dimensions. It's easy for me to say let east be positive, west be negative. Okay, so what I'm going to do here, if I can work out the force FQ1, if I can work out the force FQ3, I might as well add these forces. Okay, so let's work out FQ1. The force that Q1 exerts on Q2. We know that it's the same as the force between the two charges, like what we did in the previous example. So it's the force between these two. So it's going to be K times Q1 times Q2 all over R squared. Now, the K, we know it's a constant. Q1 is 1 microcoulombs. Micro, guys, means times 10 to the minus 6. Q2 is 0.5 microcoulombs. Notice again, I don't need the negative charge. I'm not going to place the negative charge. Now the distance is centimeters. 2 centimeters means 2 times 10 to the minus 2 divide by 100. Or if you want, you can make it 0.02. Now I'm set for my calculation. Again, I place the division sign. 9 exponent 9 times 1 exponent negative 6 times 0.5 exponent negative 6. All of that, I'm going to open a bracket again. 2 exponent minus 2 squared, get 11.25 newtons. So Q1 pulls Q2 with a force 11.25 newtons. Let me work out the force from Q3. Between the two, it's going to be K, Q2 times Q3 all over R squared. The K is 9 times 10 to the power of 9 times Q2, 0.5, 10 to the minus micro 6 times 2 times 10 to the minus 6. All of that, the distance between the two is 3.5 centimeters. Divide by 100 or times 10 to the minus 2. It's the same thing. Now, I should get a force. So what am I going to do? division sign again. 9 exponent 9 times 0,5 exponent minus 6 times 2 exponent minus 6. All of that is 3 divided by 3,5, the power of minus 2 squared. I'm getting 7,3469. 7,3469 newtons. Now, FQ3 is the positive force, FQ1 is a negative force. So how do I determine the net force now? How am I going to determine the net force? Well, I'm going to come and say the net force is a sum of Q1 plus Q3. Q1, 11,25, but it's a negative 11.25 plus a positive 7,3469. So, negative 11.25 plus 7.3469 gives me a negative 3.903 newtons. Negative means it's in the west direction. 3.9 newtons west. Okay, quick recap. Once you have more than 2 charges, draw a free body diagram. Determine the direction of the forces. Now, once you've determined the direction of the forces, go determine the magnitude of the forces by looking at the distance. Once you've got the distance and the magnitude of the forces, say the net force is the vector sum of the 2 forces. Remember to treat your vectors correctly by adding the correct signs, and then you get a net force. So that's it. So when you have 3 charges arranged in a linear fashion, approach it like this. Okay, even if the examiner twitches the question and say, well, the net force is that amount. Can you calculate a missing variable? You know that from the net force, you can come to this part and you can slowly break it down. I think that's probably one of the interesting questions we'll later look at when we have established the 3 basic calculations. What happens when we are given the force and we asked for something in there, you know? So this time around we worked this way. Free body diagram, forces, net force. Sometimes you're given the net force and you have to go back. Okay, it's almost like a good mechanic. You must not be able to just break down things. You must be able to put them together again. So good scientists must also be able to work in one direction and also work like in the backwards direction. Okay, so that's it for question 2, how to deal with assemblage of charge in a linear fashion. Sharp, sharp. Such skill.